The PC Sprint project dates all the way back to 1985. It's a simple PCB that disconnects the crystal on the motherboard from the CPU in the original IBM PC, allowing us to use a faster separate crystal and overclock the CPU. A few weeks ago, Viewer Vintage Support Service helped me with redesigned boards, small enough to fit not only the 5150, but also the 5155, the 5160, the PCjr and many clones. Unfortunately, I made a small mistake when measuring the available space in the 5150, so it wouldn't quite fit. Luckily, Thomas was patient with me and redesigned the skinny sprint to fit the 5150. So today we're going to try out the skinny sprint V2. We are also going to try it out with faster RAM chips to see if it will go any faster than in our previous attempts. But first, I think we need to start with the repair, because this poor PCjr only has 4K of working RAM. Okay, I skipped ahead here a bit, because we have already done the full disassembly of the PCjr in a previous video. So this is obviously the motherboard. I have done a test without the expansion card, so we know the fault is on the motherboard. We have previously repaired this card. It's missing a chip now, because we had to use a loaner when we did this repair. I have since then bought some new chips, so we can install a new chip today. The RAM in the PCjr consists of these 4164 chips down here in the corner. The expansion card had 2 chips replaced when I got the machine. That was easy to spot because 2 of them were in sockets. But none of these chips are in sockets. However, now that I see them up close, there are actually several different brands present here. Let's move in closer. Yeah, these are definitely not from the same batch. There are 2 different brands. This InMOS here is from 1983, and the remaining chips are from 1984. And these 2 guys here seems to be Mitsubishi. So has this board been repaired? Let's have a look underneath. Well, I can't say for sure, but all of these solder joints look factory original to me. So they seem to have mixed and matched different brands in the factory. But I'm not going to try to figure out which chip is bad, because I want them all in sockets. So I'm going to desolder all of them in one go. Because I have bought some faster chips, and I want to see if we can overclock this machine and make it go faster with faster RAM chips. These legs are bent. Slightly annoying, but not a big issue. 2 of the pins are a bit stubborn. Let's reflow them and see if we can get away with not having to preheat the board. Yeah, that worked. Yeah, that solved the problem. So next we need to straighten up all the pins before we try to remove the chip. Otherwise those bent pins are going to rip some of the pads off. I have seen mixed RAM chips in Commodore 64s, but never in an IBM. So this is a first. I'm just going to very gently feel if the chip is loose. I'm definitely not prying, just feeling, and it's still stuck in some old solder. So I'm going to use some hot air to free up those pins. If you don't have a rework station, you could reflow all the legs with some fresh solder, and more often than not that will work too. So I'm not prying, I'm just lifting the chip very, very gently. If you pull on the chip with force, you will rip one or more of these pads off. I realize there's going to be quite a lot of heat in this corner here. So I decided to preheat the entire board with just a regular heat gun to lower the risk of bending the board. If you just heat one area of the board long enough, the PCB will get bent. It's not a problem if you're just removing one chip, but in this case we're going to remove 8 chips in one of the corners of the board, so that's definitely a risk. Before we continue, I'd like to say thank you to PCB for sponsoring this video and supplying these PCBs for us to try out today. I have been using their PCBs for years now, and I'm really happy with the level of service and the quality of these PCBs. This is just a few of the projects we have built on this channel. So head over to PCBWay.com and order some PCBs for your next project. Thank you PCBWay for supporting this channel. I ended up increasing the heat on the desoldering gun to 390. I still had to reflow several of the pins, but I tried to keep the heat on the low side. I also heated up the entire board several times to keep the board nice and warm. When it comes to heating up the legs of the chip, when I remove it, I take my time. I rather kill a RAM chip than pulling one of the pads off. This guy here was really stubborn. There we go. If I killed it with too much heat, I don't really care, as long as the pads are fine. A chip like this costs next to nothing. I still have some stubborn solder left in few of the through holes, so I will reflow it and remove it with the desoldering gun. Solder wick would do the job too. Not a difficult board to work on, but it's not the easiest either. I think this should be enough. Doesn't have to be perfect, because the pins of the socket are much thinner than these through holes. Next we can install sockets. To prevent the sockets from falling out while we do the soldering, I like to use electrical tape, because it's very easy to remove when we're done. Next I solder two of the pins roughly in the middle of the socket. One pin on each row. Now we can remove the tape and make sure that all the sockets are flush and straight. In this case they're not. So I will reflow these two pins and straighten up this socket before I move on. Well, not perfect, but good enough for me. The only thing left to do now is to solder the remaining pins. And we should be ready to test this board with a new batch of faster RAM chips. You don't need faster RAM chips to overclock the PCjr, but I'm curious to see if we can make it go a little bit faster. It's pretty much impossible to know which part sets the limits, but at least it won't be the RAM chips today. But of course, pretty much any chip on this board could set the limit for how fast we will go today. RAM chips are cheap and easy to find, and if they don't make this board go faster, I can always reuse them in another project, like replacing some empty RAM chips in Commodore 64s. In this case we had to pull at least some of these RAM chips to test them and see if one of them is faulty. I'd say that is very likely. By the way, next week I will be traveling, so I'm not likely to be able to make a video. If I'm lucky, I will have one day or so to make a video. In that case I will try and at least make something short. I'm off to Egypt, by the way. It's been at the top of my bucket list for at least 5 years. So now I finally get to see those stupid pyramids. I'm not sure why, but I find them absolutely fascinating. Perhaps because they don't make any sense. Why would anyone build huge pyramids in the bloody desert thousands of years ago? It's a really odd thing to do. Well, I guess I just got bored. I suppose there isn't much to do in the desert. Before we do the tests, I better clean this flux off. Okay, that's clean enough for me. By the way, I tend not to push on the pads with a desoldering gun when I wiggle. That way the board doesn't get all scratched up and ugly. Well, I'll do an inspection and then we can find out if this was caused by a bad RAM chip. So these original chips are 4164-15, so they are 150 nanosecond chips. And the chips I ordered are 4164-10, so these are 100 nanosecond chips. Don't know if it's going to help, but these guys are faster. So let's get these guys on the board. These are, by the way, from eBay. But I've been pretty lucky with chips I bought on eBay. Sometimes they are used and not new old stock as advertised. But generally they do work. Now let's find out if these do. Oh no, something is wrong. I'm getting nothing on the screen. That's not great. Well, we've had 2 angry beeps and a black screen before in this project. That's exactly the fault we had with the bad chip on the expansion card. So my best bet is that one of these chips is bad. Let's see if one of them gets hot. No, they're not. Okay, let's change tactics. 3 of the RAM chips on the expansion card has already died. And the error we've got is clearly a RAM error. I don't have a fancy chip tester, but I do have a Commodore 64 and a dead test cartridge. This Commodore already has 4 RAM chips in sockets. So without doing any further soldering, we can test 4 RAM chips in one go. And no wonder it has 4 sockets, because the original RAM chips are MT branded. So this board is going to get a full set of sockets eventually. But I'll leave them in, as long as they last. All we need to do now is to run the tests, and it will tell us if we have a bad RAM chip. Well, this is interesting. Never seen a RAM chip cause this. All but one chip is tested good in this machine now. And I'm going to test the new chips one by one. This isn't going to be fun to watch, so I guess I'll skip ahead.
One eternity later.
I noticed when I tested these chips that they still had some old solder left on the legs. So the batch of chips I got are reused desoldered chips. So I'm going to add some deoxit in all the sockets. Okay, 8 tested RAM chips in sockets. Fingers crossed. Okay, the floppy drive woke up. Oh, we better turn the display on. 1 beep. And 2 more beeps. What the heck is going on here? Well, these 2 guys up here are happy, but I'm not. What is this? We've got a bunch of weird characters. Then delete and syntax error, and now it just keeps beeping. I have no idea what this is, but I need to turn that beep off. Let's boot again and see what happens. It tries to read from the floppy. Now it goes to basic. So now everything is okay. So what was that crap we got on the previous boot? I think I need to make a test for consistency. So I will reboot the machine a few times. By the way, this IBM is not overclocked right now. It's running off the original crystal at normal speed. Well, I turned the machine on and off a few times. I think this is reboot number 5. Now we're getting a black screen. Now it boots again. So something is glitchy. Oh, I hate these type of faults. They don't give you any clues. Where do you even start looking for a fault like this? I wonder if there's a test cartridge for these machines. Okay, 5 more reboots. And it just works perfectly. Well, the only clue we have is that we're using desoldered reused chips. So I'm gonna place my bets on a bad connection here. I'll add some more deoxit and reseat all the RAM chips. Just by pulling these chips out and then reinstalling them in deoxit, there's a good chance that if there is some corrosion on the legs, it will get scraped off. Deoxit by itself is often not enough. You often also need to pull the chip in and out a few times to get the corrosion off the legs. Okay, let's try again. Okay, 5 reboots in a row, and it takes us to basic every time. Let's try with a floppy. Well, it seeks, and I think it reads. We've got a splash screen. So aside from a bad RAM chip, I think I also just had bad connection. So I think we have a working system now. Next we need to test 8 more of these chips to fill up the expansion card.
One eternity later.
Okay, 8 more tested chips. I'll add some deoxit in these sockets too, to make sure those reused chips will make good contact. If you're playing along, be careful when you reinstall chips on these boards, because the notch is pointing in 2 different directions, so it's easy to make a mistake here. Okay, time for a test. First a quick test without the expansion card, just to make sure everything is still okay. And it is. So let's add the expansion card with those fast RAM chips. Fingers crossed. Okay, we've got 128 KB now. And the machine boots to basic. Okay, great. Let's do some overclocking. So this is the classic PC Sprint. This one is actually missing some pin headers here, but that doesn't matter. This board is slightly redesigned by Retro Canada. And this here is the skinny Sprint. It has the crystal really weirdly soldered here. I did that on purpose, because I wanted to be able to remove it quickly. It would normally sit flush on the board. By removing the 8284 on the motherboard and move it to this socket here, we can then install this PCB instead of the 8284 chip. The CPU will get a separate 8284 and crystal. That way we can overclock the CPU without affecting the speed of the rest of the board. However, as I mentioned, I made a mistake when measuring the 5150. So there wasn't room enough for a socket and a chip here. There wasn't room enough underneath the floppy drive. That's why this chip here is soldered directly to the board. And here's the Skinny Sprint V2. Check out that logo. That looks awesome. I obviously should have ordered these PCBs with gold. That logo would have looked awesome in gold. But no worries, I'll order the next batch with plenty of gold. The important thing today is to test this board and make it available somehow for you guys, so you can start overclocking your machines. So let's build one up and try it out. Okay, let's start with C1 here. C1 is a 10 nanofarad cap, and apparently it's my last one. Unlike the classic Sprint, these boards use surface mount components to make them as skinny as possible. Moving on to R1. R1 is a 3.3K resistor. This may actually be a good beginner's project if you want to try out soldering SMD components, because there aren't that many on this board. Moving on to C5, and it's a 10 microfarad tantalum. Being a tantalum, you have to check the polarity. C2 is also a 10 microfarad tantalum, but it's mounted in a reverse direction, so pay attention. The polarity is clearly marked on the board. I have the board stuck down to the bench with sticky tape, so I'm gonna have to solder the other side later. R2 is a 10K resistor. Tiny little bugger when soldering surface mount components. I use Flux, and then I just add a small blob of solder to the tip. I then hold down the component and let that blob find its way to the pad. And the resistor R6 is a 560 ohm resistor. I should probably try solder pastes for projects like this. C3 is a 10 microfarad tantalum 2, soldered in this direction here. With the board flipped, I can solder this side of the tantalums. I'm using a pine sill, by the way, with the smallest tip available. I've been using it for, well, I think it's 2 years now. And it works really well. It's quite incredible what you can get for very little money nowadays. Last but not least, we have two diodes down here. U4 and U5. And they are 1N4148 diodes. Polarity is clearly marked on the board. And the diode. The most difficult thing with building up one of these boards is to get it on camera. I was a bit worried I would run out of components, but apparently I had enough components to build one of these up. Okay, time for some cleaning before the inspection. Well, I let that pass inspection, but it was a bit too much solder. To finish this off, we need angled pin headers. 2 sockets and this type of pin headers cut to size. The angled pin headers go on the edge like this. These pin headers are for the turbo and the reset switch. It's very cool that it got that logo in the silk screen. Sockets are for U3 and U2. Well, we have done plenty of these today. These boards aren't much wider than the sockets. Nice and flush. So we can solder the remaining pins. The reason why they are so skinny is because they sit very close to the ISA slot in the 5160 and the 5155. The original Sprint wouldn't quite fit. I was able to make it work with a bunch of sockets, but it made the board very flimsy. When installed, these boards sit very firmly in the socket. I like to use a machined socket on a breadboard when I solder pin headers like this. Oh, what's up with this solder blob? Okay, time to pick the crystal. I ended up ordering a huge variety of these, because I don't really know how fast these machines will go. Let's start with a 24.5 MHz crystal. That gives us 8.2 MHz CPU clock. This is the fastest crystal we tried in the PCjr in the previous attempt. So this should be a good test of the skinny Sprint. I'm soldering it like this to make it slightly easier to replace, because we are obviously going to try faster crystals today. Instead of a turbo switch, I'm just going to use a jumper today to save some time. This jumper sets the Sprints in constant overclocked mode. To install the Sprint, we need to remove the 8284 that sits just behind the floppy drive here and install it in one of the sockets. Since we are reusing that chip, you only need to order one 8284 chip. These are quite easy to find on eBay. The Sprint now fits in the socket on the motherboard. I have checked and there is enough clearance here in the case. The main difference with this version of the Sprint is that the crystal has moved from this position to this position here. And these two sockets, they have moved in this direction, making some extra room over here for the floppy drive in the 5150. Okay, fingers crossed. Let's see if it works. Well, we've got splash screen and 128 KB. I've got King's Quest in the floppy drive. I can actually see some occasional pixels displayed randomly on the display. And Graham is in a hurry. is running at 8.2 megahertz. Yeah, I think we are pushing the system to its limits already, because there are occasional pixels that are popping up in random places. But let's push it some more. Let's make sure those white pixels aren't caused by yet another faulty RAM chip. So back at original speed. Oh man, it's slow now. Really slow. Oh, I forgot. Wireless keyboard. So the keyboard must be in front of the machine because it's wireless. And Graham definitely slowed down, running at 4.77 megahertz. No, I can't see any random white pixels. So we really are pushing the limits with a 24.5 megahertz crystal, running the CPU at 8.2 megahertz. Next up is a 25 megahertz crystal. So a very small step up. Let's see if it works. Yeah, I hope the camera picks this up. But there are random white pixels. But they are few and far between. So the machine is perfectly usable. They don't seem to show up in the green areas on this screen. Only in this blue area. So machine is still usable and the game is still playable. Well, let's push it some more. Next up we have a 26 megahertz crystal. So we're taking rather small steps. Let's see if those white pixels got worse. No, I think it's about the same. Perhaps a few more. So in this screen I can hardly see any. But in this lake here they are quite plentiful. Makes the water look like it's sparkling. Well, let's push it and see what happens. Okay, we have reached 27 megahertz. So this is the crystal that wouldn't work in our previous attempt. Let's find out if those faster RAM chips made any difference. Okay, we've got the splash screen. Ah no! They didn't. So changing to faster RAM chips doesn't help. And 26 megahertz is the limit for the PCjr. Could be pretty much any or many chips that sets this limit. But I'd be happy to try out some more, so if you have any suggestions, I can swap some suspect chips and see if we can make it go any faster. But for the time being, 26 MHz is the fastest crystal it will take. I'm sounding kind of disappointed here, but a 26 MHz crystal gives us a CPU speed of 8.7 MHz. So that is quite a bloody speed increase from 4.77. To be perfectly accurate, a 24.5 MHz crystal is sort of the limit too. Because with the 25 MHz crystal, we did introduce some occasional white pixels on the screen. Okay, let's find out if this new version will fit the 5150. It does. Well, it's a bit hard to get the camera in here, but there is roughly 1 millimeter of clearance between this chip here and what I presume is a resistor here. So that's a win. We might as well test the crystal since we have the board in the machine. So in the previous attempts, the 5150 would go to 22.1 MHz crystal. When we tried at 24.5, we got a RAM error. So let's take a tiny step from 22.1 to 22.6. Well, it beeps and we have a cursor. Configuration too large for memory. Ha. That sounds more like I have set the switches incorrectly on the motherboard. Let me check. No, they were actually set correctly. I only have 64K on board, and the switches are set to 64K. So let's try it at original speed, without the sprint. Okay, so... not sure what this means. I guess I have a bad RAM chip in this machine. Although I can't set the switches to less RAM than 64. Because with less RAM in this machine, the switches should be set the same way. Well, I don't have the time to troubleshoot this machine, unfortunately. Well, that was a fail. Well, this is pretty bizarre. I decided to make one more test. So I installed the RAM expansion card and changed the switch block for 320K. And now the damn thing boots. I have no idea what's going on here. So feel free to share your thoughts if you have any. Well, I guess we might as well overclock it while it's working. Okay, fingers crossed. We've got a cursor and it sounds like it boots. It does. Okay, so that was a tiny step up. But now we know the Skinny Sprint V2 works. And this machine will go to at least a 22.6 MHz crystal. But something is glitchy with the RAM, obviously. So this machine will probably be back in a repair video. In that video we are also going to push this machine to its limits and see how fast it will go with the Skinny Sprint. I also want to take this machine to 640K. So I think I have enough stuff to do for a video. But for now, I'm gonna call this a win. Moving on to the 5160. Here you can clearly see why the Skinny Sprint is so skinny. It sits flush against the ISA slot here. This machine has a turbo switch and a reset switch at the back. So here are the wires connected. They are going to this reset switch here. And the turbo switch. Well, Skinny Sprint V2 fits perfectly, as expected. And these boards are extremely sturdy. It won't budge, even if I press really firmly. I guess that's the main benefit in the 5160 compared to hacking one of the classic boards. Same thing with this machine, we might as well try a slightly faster crystal. So the fastest crystal we could use in the 5160 in our previous attempt was the 22.1 MHz crystal. So let's take a tiny step up to 22.6. Let's see if it works. I don't remember what error we got. I think we got a black screen when we tried with a 24.5 MHz crystal. Well, it's counting up the RAM. We've got beeps. And it boots. Okay, so that was an absolutely tiny step up. But still, this video is more about testing how fast the PCjr would go. And test if the Skinny Sprint V2 would fit all the machines. Well, the XT is still slightly too slow to play Prince of Persia. I think it's because we're playing with AdLib sound and EGA graphics. I have not done any tests to confirm it. In any case, that's how I want to play it, so we need to get this machine faster. I will of course push it to its limits, but that will have to be for a separate video. Not sure what more we should do with this machine in that video. Suggestions are always welcome. And that was a good time to watch the video where we restore this IBM XT, if you haven't watched it yet. I'd like to end this video by saying thank you to my patrons. Thank you for your support. If you want to become a supporter of this channel too, consider becoming a patron. You can use the link in the description. Patrons get early access whenever possible. You can also support me with a like and a comment. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you soon again.